Good afternoon, class. I'm Mr. Draper, and today we're going to go over our 6 homework problems from Math for Teachers 1, Lesson 3. Got all my speaker notes and whatnot ready here. Whoop. Let me start the slideshow. Okay, this is Math for Teachers 1, Lesson 3. As I was saying, I'm Tyler Draper. Nice to meet everyone. Problem number 1, it says use the divisibility test to decide 2, 3, 4, 5, 6, 7, 8, 9, and 10, and 11. We're just going to go over 684 here. The rest are, I have all the rules posted. 684 is divisible by 2. It ends in a 4. If a number ends in 2, 4, 6, 8, or 0, it's divisible by 2. To determine 3, what we will do is we will add up all the numbers. So 6 plus 8 plus 4 equals 18. That is divisible by 3, so yes. 4 here, you add up the last two numbers. 8 plus 4 is 12, and 12 is divisible by 4. 5, it's not divisible by 5. That one's pretty simple. If the number ends in 5 or 0, it is divisible by 5. To determine number 6, it has to be divisible by both 2 and 3. This number is, therefore it is divisible by 6. To determine 7, that is probably the toughest one. We will cross off the last digit, double it, and subtract it. Now, if the new number would be divisible by 7, then it will be divisible by 7. 684 is not. For number 8, if the last 3 digits is divisible by 9, 6 plus 8 plus 4 is 18, so it's not divisible by 8. Number 9, we add up all the digits. 6 plus 8 plus 4 is 18. We know that that is divisible by 9 because 9 goes into 18 twice, so it is. That's a yes. 10, no. 10 is very simple. If the number ends in 0, then it will be divisible by 10. Number 11, so subtract the last digit from the number formed by the remaining digits. If a new number is divisible by 11, then the original, and this one is not. Okay, and there's all kinds of other numbers in this. I've already done them if you want to take a look at them. We have all the rules posted, and we can figure those out. Problem 2, we're going to do the processes of 9. So each time we're going to add up all the digits of each number and divide it by 9 to determine a remainder. For example, 416 plus 7,490 plus 69,844 equals 112,790. So we see here 4 plus 1 plus 6 equals 11. 11 divided by 9, we get 1 remainder 2. 7 plus 4 plus 9 plus 0 equals 20. 20 divided by 9 is 2 remainder 2. 6,000, excuse that 2, 6,908. 6 plus 9 plus 8 plus 4 plus 4, we'll get 3 remainder 6. So we see that our left side of the equation, our remainders equal 10. If we add up the answer, we see that we have a remainder of 2. So we see that there is a problem there. Based on our casting of 9s, you see that there's an error in the calculation. So if you re-add that problem here, 416 plus 7,490 plus 69,844, that equals 77,750. Not what it answered here. So that was wrong. So we see there's an error. The given answer has a remainder of 2. And our casting of out 9s gives us a remainder of 8. The correct answer is 7,750. This is problem B. So 8,550 plus 6,888 plus 2,525 plus 6,029 equals 23,892. First thing we want to do here, we get that the digits of our answer equal 24. That's 2 remainder 6. Now when I say 2 remainder 6, remember each time we're dividing by 9. So 9 plus 9 is 18 plus the 6 is 24. Remember, dividing by 9 every time. I wrote this out. We have our answers, or the other left part of the equation. We get remainder 0, 3, 5, and 8. So those 4 numbers become 0, 3, 5, and 8. So 16 is the addition of those. We have 1 remainder 7. Based on casting out 9s, there's an error in the calculation because our answer has a remainder of 6. This one has a remainder of 7. Correct sum, after we add it up, we see that the answer was wrong in the first place, and it was 23,992 is what it's supposed to be. So casting out 9s, the given answer has a remainder of 6 right here. We found a remainder of 7. The correct answer is 23,992. C, okay, now we're going to do some subtraction. Still the same thing. We're adding the digits, dividing by 9. So our answer, given answer, 74,678. We find that after you add them up, you get 32. The digits up, you get 32. 3 remainder 5. 7, 8 plus 6 plus 6 plus 2. Our answer on our addition problem on the left. Or sorry, our coefficient on the left. My apologies. You get 3 remainder 2. Same for the next one. You get a remainder 2. So we find that we have a remainder of 0 on the left and a remainder of 5 on the right. There's a problem. We see that there's an error in the calculation, and we determine the real answer should be 74,988. That one is wrong in the given. We find that there's a remainder of 5. We see there's no remainder on the left, and the correct answer is 74,988. Last problem here, we're going to do multiplication. Same thing. We're still doing the processes of 9s. 337 times 620 equals 209,940. 209,940. We get 24 here. 2 remainder 6. 337, 13. Add the digits, get 13. 1 remainder 4. Next one, 620. We get a remainder 8. So 337 times 620 becomes 4 times 8. We get 32 there. 32 divided by 9, you get 3 remainder 5. We see that based on casting out 9s, there's an error in the calculation. 337 times 620, you get 208,940. So casting out 9 shows there's an error. The given answer has a remainder of 6, but casting out 9s gives a remainder of 5. The correct answer is 208,940. Okay, we're through that. Now problem 3. We're looking at these colored blocks here. Let's look at problem A. Show which rods will measure the 9 rod. So we're just looking for what is 9 divisible by. You know, 1 times 9 is 9. 3 times 3 is 9. So what it's saying is 9 of these little 1 blocks will make 9. 1 of these 9 blocks will make 9, and 3 of these 3 blocks will make 9. Same goes for the next answer for the measure of 6. So 1 of these times 6 will get a 6. 2 or 3 of the 2's will make 6. 2 of the 3's will make 6. And 1 of the 6 will make 6. So it says use parts A and B to show the greatest common divisor. We see that we have our factors 1, 3, and 9, 1, 2, 3, and 6. Which number has of this factors do they share that is the highest? Well, we see that it's 3. So our greatest common divisor of 9 and 6 will be 3. Place the 10 rod and the 8 rod end to end to form an 18 train. Show all rods are trained that will measure the 18 train. Recall that a train is formed when 1 or more rods are placed end to end. Okay, so it's going to be 18 in distance. And our divisors of that will be 1, 2, 3, 6, 9, and 12. So, 18. That's supposed to be 18. 1 times 8, or 18 of the 1 white blocks will get you an 18 rod train. 2 of the 9 blocks will get you an 18 train, and 3 of the 6 will do the same. So show all the lengths of all rods or trains which can be measured from the 18 block. Okay, let's see. So we can have 18 of the white ones to get us to 18. We can have 2 of the 9 ones, or we can have 9 of the 2 blocks. We can have, or 6. We can have 3 of the 6, or we can have 6 of the 3. These are all just factors that make up the train that we can use. These are all of our possibilities that we can use to make an 18 block train with our factors. All right, problem 3F. Demonstrate how you might use these color rods to demonstrate the notion of greatest common divisor to children. Okay, so the greatest common divisor of two numbers, R and S, is the length of the longest train or rod that will measure both the R train and the S train. For example, we have our R train that equals 3, our S train equals 6. R plus X equals RS. So R is 3, S is 6, our train is going to be 9. Now, we know both of them have a factor of 3. That's going to be our greatest common denominator. So we can use 3 as our GCD for that equation. I hope that gives you a better example and that we can use to teach children. Problem 4, the LCM method. What we're going to do with this one is we're going to factor out any prime divisor of the terms, and we want to get, divide it all the way down till they can't be divided anymore, and we'll start using that with this one. So A, it asks to find the least common multiple, 48, 25, and 65. We have our numbers here, 48, 25, 65. These are going to be our factors. First, we're going to divide by 3. Now, this is important. When we divide, sometimes a number may not be divisible by that, so it stays the same and you pull it down. 48 divided by 3 is 16, bringing 25, 65. Next, we're going to divide by 5. The 16 doesn't change, but the 5 does. So 25 becomes 5, 65 becomes 13. And we just keep dividing it down until we see it cannot be divided any further. We see this here. We got 1 3 here. We have 2 5s, 1 2, 4 2s, 1 2 3 4, and we have 1 13. All right, problem 4. This is B. As we see with our least common multiple, we have added 4. We have 4 numbers instead of 3, so we're going to add an extra block on the graph. Divide by 2. We're breaking it all the way down to get 26, 22, 363 stays the same till we'll divide that by 3, then 11 until we get all of our answers here. We get 1 to the 3rd power times 2 to the 3rd times 3 to the 1st times 11 to the 2nd. I hope you're able to see how we're doing this. We have all of our factors right here on the sides that equal up, and that's our least common multiple factorization. Problem 4, this is question C. Now, this one says divide each row down until it cannot be divided anymore. So we literally, right here, we're going to get to this step where we have 11 and 11. And we divide this by 11 because we have to get it all the way down. We want the smallest numbers possible. So we divided 11 and 11 by 11, and we get our 1s that we just keep bringing down. And as you can see, this one has a long factorization. We have 2 1s here. We have 2 2s, 2, 2, 3 5s, 1, 2, 3, 1 7, 7 there, and we have 1 11. Whereas, so if we wouldn't have divided this by 11 here, we would have had 2 11s, and that would not have been divided all the way down. So you got to make sure you divide. We're dividing all the way down as smallest as possible till it can't be divided anymore. Problem 5. This is the least common multiple problem. So it says in a machine, a gear with 48 teeth is engaged with a gear with 84 teeth, with teeth A and B on the small and large gear. We're basically looking to see when is the next time 48 and 84 will meet again. Okay, so we have 48 all the way factored down to 2 to the 4th power times 3. 84 is 2 to the 2nd power times 3 times 7. What we're going to do is use the greatest factors for each one to multiply. So we have 2 to the 4th. We'll use that one. 3 and 3, they're both the same. We'll choose 1. And then 7, you get 336 is the least common multiple. Or you can do it the old-fashioned way. That takes forever. 48 plus 48 is 96, plus 48 is 144, plus 48. Okay, you get the problem. Okay, you get it. Then 84 plus 84 plus 84. And then we see 336. This is a simple method, but if you get large numbers, you may be in there for a while. So this is the way to go. Prime factorization. Shortcuts and simple methods will save lots of time. Now, once we find that 336 is the least common multiple, we need to divide it by 48 because we are trying to determine how many times 48 goes into that. We see that 48 goes into 336 7 times. I'm going to show you an example here. So this is the 84 teeth. This is our 48. So as 48 is making one loop around, we know that, or as 84 is making one loop, 48 has to make 7 until they meet up again. So here we go. We got 84 moving. 1, 2, 3, 4, 5, 6, 7. That's so 48 has to spin 7 times before it meets 84 once. So we have a ratio of 7 to 1. I hope that makes sense for y'all. That's a really fun equation. I love that one. Thank y'all. Number 6. This one is a very, if you like math games, if you've ever played Sudoku, this one is very similar to that. We call it the magic square. We're looking for magic numbers. And this one is stressful. Take you a long time to do it, but once you do it, you feel really accomplished, and it's fun if you like math games. So our numbers are -7, -6, -5, -4, -3, -2, -1, 0, and 1. To find our magic number, this is very important. You have to add them up. So -7 plus -6 plus -5 plus -4 plus -3 plus -2 plus -1 plus 0 plus 1 equals -27. Now, our magic number is not -27. Let me say that again. Our magic number is not -27. Our magic number is determined by dividing that by how many, what the length and width is. We know squares have the same length and width. Now, this square that we're using is what we call 3 by 3. Since this square is a 3 by 3, we need to divide -27 by 3. If this square was a 4 by 4 or a 100 million by 100 million, we would divide that number by the half. Okay, so remember, always divide our whole number of all of our possible answers by the length and width, or by the length or width, sorry, of the square. So we divide by 3, and our magic number is 9. Now, when we say our magic number is 9, that means each row, each column, and each diagonal has to equal -9. We are given 0 and 1. So we see 0, -5, and -4 equals -9. -7 plus -3 plus 1 equals -9. -2 plus -1 plus -6 equals -9. 0 plus -7 plus -2 is -9. -5 plus -3 plus -1 is -9. -4 plus 1 plus -6 is -9. Now, this is the part where I messed up, and I want to bring special attention. Your diagonals have to match -9 too. When we say diagonal, we think of an X, okay? We got straight, horizontal, or sorry, vertical, horizontal, diagonal. -4 here plus -3 plus -2 equals -9. 0 plus -3 plus -6 is -9. We have solved this this box. These usually take a little bit of time to do. If you just mess around and play with your numbers, I've done about 20 or 30 different cards to determine this one. It's fun, and once you figure it out, you really feel like you could solve rocket science and send us up to space. I thank you for tuning in today, class. Thank you so much, and I have a funny math joke to give to you guys. We all like divisibility, but it's weird how if a number it's odd when a number is not divisible by 2. So that's why I don't like divisibility rules. All right, thank y'all so much. Have a great weekend. Have a great day.